Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. When workloads require shared file storage rather than block or object storage, AWS offers two main categories of managed solutions: Amazon Elastic File System, EFS, and the Amazon FSx family. Both are fully managed services that provide scalable file systems, but they target different needs. EFS is designed as a regional multi-AZ file system offering Linux-compatible NFS semantics. FSx, in contrast, delivers specialized managed file systems such as Windows File Server for SMB, Lustre for high-performance computing, or enterprise-grade NetApp ONTAP and OpenZFS for hybrid and advanced data management. Together, they allow customers to replace self-managed file servers with cloud-native or enterprise-grade managed file systems. Amazon EFS is the default option for shared Linux-based workloads. It provides a regional file system that automatically replicates across multiple availability zones, ensuring both durability and availability. Access is via the NFS protocol, which makes it compatible with a wide range of Linux workloads. Unlike block storage volumes that can only attach to a single instance, EFS supports concurrent connections from hundreds or thousands of EC2 instances, allowing true shared file access. This makes it a natural fit for content management systems, web applications, or container clusters, where multiple nodes need consistent file access. One of the strengths of EFS is its support for POSIX semantics, which ensures compatibility with Linux file operations. POSIX compliance means standard Linux permissions and operations behave as expected, allowing developers and administrators to migrate existing applications without modification. Features like file locking, directory traversal, and permission enforcement make EFS behave like traditional on-premises file systems, while still benefiting from AWS scalability and resilience. This seamless integration with Linux environments is what sets EFS apart from other storage services like S3, which lacks POSIX semantics. EFS offers different performance modes to align with workload needs. General Purpose Mode is optimized for most workloads, providing low latency suitable for web serving and content management. Max I/O Mode scales to higher levels of aggregate throughput and operations, making it ideal for parallelized applications like big data analytics. Choosing the right performance mode ensures applications receive the expected balance of throughput and latency. For example, a CMS would thrive on general purpose, while a machine learning pipeline with distributed training might require max I/O for higher concurrency. To complement performance modes, EFS provides throughput modes: bursting, provisioned, and elastic. Bursting is the default, scaling throughput with the size of the file system and providing credits for short-term spikes. Provisioned throughput allows administrators to set fixed throughput levels regardless of file system size, which is useful for workloads with steady, predictable demands. Elastic throughput automatically scales to match workload needs, removing the need to pre-provision capacity. These modes allow EFS to adapt economically and operationally, from small web servers to massive analytics clusters. Storage in EFS can also be classified into different storage classes. EFS Standard provides multi-AZ redundancy and maximum availability. EFS Infrequent Access IA stores less accessed files at a lower cost, with lifecycle management rules moving files automatically between standard and IA tiers. EFS One Zone stores data in a single availability zone at reduced cost, trading redundancy for price efficiency. This flexibility makes EFS more cost-effective by aligning data placement with access patterns, ensuring organizations do not overpay for files that are rarely accessed. For multi-tenant applications or scenarios where file systems need segmentation, EFS access points provide per-application entry points with unique root directories and enforced permissions. Access points allow administrators to control how applications and users see the file system, ensuring boundaries within a shared resource. For example, multiple teams can use the same EFS file system but only see their own directories, simplifying management. Access points streamline deployments in containerized and serverless environments by providing clear, enforceable access scopes. Security in EFS relies on a combination of security groups, POSIX permissions, and encryption. Security groups control which EC2 instances or VPC subnets can mount the file system, while POSIX permissions manage access inside the file system. Encryption at rest is supported through AWS KMS, while encryption in transit protects data as it flows over NFS. These layers of security ensure that EFS aligns with modern compliance and governance requirements. Administrators can also integrate IAM policies with access points for finer-grained control in multi-application scenarios. Operationally, EFS uses mount targets within VPC subnets to enable access. Each availability zone requires at least one mount target, ensuring that local traffic can access the file system with minimal latency. Proper VPC integration is critical to achieving the expected performance and security. By controlling mount targets and associated security groups, administrators define which resources can reach the file system and under what conditions. This integration ensures EFS operates as a natural extension of the private cloud environment rather than as an isolated service. EFS also integrates with backup and lifecycle policies, ensuring that data durability is paired with economic efficiency. Lifecycle management automatically transitions infrequently accessed files to the IA class, reducing costs without losing availability. Additionally, EFS can be integrated with AWS Backup to provide centralized, policy-driven snapshots and retention schedules. These capabilities reduce administrative burden and align file system operations with organizational compliance needs, ensuring both cost control and resilience. For hybrid environments, EFS can extend beyond AWS through on-premises access over VPN or AWS Direct Connect. By mounting EFS volumes from on-premises Linux servers, organizations can use it as a bridge for migration or hybrid workloads. This allows enterprises to centralize storage in the cloud while still supporting legacy applications or transitional environments. The ability to mount EFS from both cloud and data center infrastructure makes it a versatile option in hybrid architectures. While EFS serves Linux workloads, the FSx family extends AWS file services to specialized use cases. FSx for Windows File Server provides a fully managed Windows file system using the SMB protocol, complete with Active Directory integration and user quotas. This makes it ideal for enterprises migrating Windows-based file shares into AWS. FSx for Lustre targets high-performance computing, offering extremely low latency, high-throughput access, and direct integration with S3. FSx for NetApp ONTAP provides enterprise-grade features like snapshots, cloning, and both NFS and SMB support, catering to organizations with sophisticated data management needs. Finally, FSx for OpenZFS delivers low-latency, POSIX-compatible file systems with snapshot support, appealing to organizations familiar with the ZFS ecosystem. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When mapping use cases, Amazon EFS is the default choice for Linux-based applications that require shared access. Content management systems, web applications, development environments, and Kubernetes clusters often need multiple instances to read and write to the same dataset simultaneously. EFS provides NFS-based, POSIX-compliant file storage that fits these needs perfectly. It scales elastically, so teams don't have to predict storage size in advance. And it works seamlessly with auto-scaling environments where compute nodes come and go but require consistent, shared storage. For workloads built around Linux and open standards, EFS is the most natural fit. In contrast, FSx for Windows File Server is tailored to workloads that depend on the SMB protocol and tight integration with Active Directory. This makes it invaluable for enterprises migrating traditional Windows file shares into AWS without rewriting applications. Features like user quotas, file locking, and DFS distributed file system namespaces allow it to act just like on-premises Windows servers, ensuring compatibility for business applications. For organizations heavily invested in Microsoft ecosystems, finance teams running shared Excel documents, design teams using Adobe files, or back-office systems depending on Windows-based shares, FSx for Windows provides a straightforward, managed path. FSx for Lustre addresses a different world: high-performance computing, HPC. Lustre is an open-source file system renowned for extreme throughput and low latency, capable of scaling to hundreds of gigabytes per second. FSx for Lustre integrates directly with Amazon S3, allowing data to be stored cost-effectively in buckets and linked to Lustre for processing. This makes it an ideal scratch file system for workloads like seismic analysis, genomics, rendering, or machine learning training, where massive datasets need to be processed at high speed. By combining S3 for persistence with Lustre for performance, organizations achieve both scalability and efficiency. For enterprises with advanced storage needs, FSx for NetApp ONTAP provides a familiar and feature-rich platform. It supports both NFS and SMB protocols, allowing mixed environments to share the same storage system. ONTAP brings enterprise features like snapshots, cloning, thin provisioning, and tiering to cloud storage. These capabilities allow organizations to replicate the operational maturity they have on-premises while leveraging AWS's scalability. For example, a software development team can use snapshot and cloning capabilities to create test environments instantly, while production systems benefit from the same data management maturity they are used to in on-premises NetApp deployments. FSx for OpenZFS offers yet another angle. Based on the OpenZFS project, it provides low-latency NFS-based storage with support for snapshots, compression, and advanced data management features. Its simplicity and strong performance make it a compelling option for organizations already familiar with ZFS in on-premises deployments. For developers and teams seeking fast, POSIX-compliant storage with a familiar toolset, OpenZFS offers managed simplicity without sacrificing the advanced capabilities ZFS users expect. It balances ease of use with strong performance, making it suitable for everything from analytics clusters to developer sandboxes. Performance tuning across EFS and FSx services involves matching throughput, I/O patterns, and sizing to workload demands. With EFS, administrators select throughput modes and performance classes that balance cost against concurrency. With FSx, tuning often involves adjusting file system size, IOPS allocations, and integration with network configurations. For example, Lustre excels at sequential workloads, while ONTAP's cloning and tiering reduce I/O overhead in mixed patterns. Understanding the nature of your workload, sequential versus random, bursty versus steady, ensures that performance features are used effectively and cost-efficiently. Data protection is built into these managed file systems but varies by service. EFS integrates with AWS Backup and offers lifecycle management for cost-effective archiving. FSx for Windows includes features like shadow copies for point-in-time recovery, while FSx for ONTAP and OpenZFS leverage snapshots and cloning to protect against corruption or accidental deletion. Lustre, focused on performance, is often paired with S3 for durability, keeping data safe outside the scratch environment. Each service's backup and recovery model reflects its use case, ensuring that durability complements performance rather than hindering it. Hybrid patterns are another strength of EFS and FSx. EFS can be mounted on-premises over VPN or Direct Connect, serving as a bridge for gradual migrations. FSx for Windows integrates with on-premises Active Directory, ensuring seamless authentication for hybrid deployments. ONTAP and OpenZFS extend their familiar features into AWS, enabling organizations to unify cloud and data center file systems. These hybrid patterns allow enterprises to adopt cloud gradually, maintaining continuity for users and applications while introducing the scalability of managed services. Security across all services follows AWS's least privilege principle. EFS relies on security groups and POSIX permissions, while FSx for Windows integrates with Active Directory access controls. Encryption is ubiquitous, with KMS ensuring data at rest is secure and TLS handling encryption in transit. ONTAP and OpenZFS bring additional controls like snapshot immutability and granular NFS/SMB permissions. By layering AWS networking, encryption, and file system native controls, administrators ensure that sensitive data remains protected while maintaining usability for legitimate users. Cost optimization is critical when working with managed file systems. EFS's infrequent access class and lifecycle policies can dramatically reduce costs for seldom accessed data. FSx services vary in pricing based on storage capacity, IOPS provisioning, and throughput, requiring administrators to right-size deployments. For example, a Lustre file system used only for periodic processing can be spun up temporarily and then shut down, avoiding ongoing costs. Thoughtful selection of storage classes, lifecycle policies, and sizing ensures that managed file systems deliver value without overspending. Monitoring ensures file systems perform as expected. CloudWatch metrics and alarms provide visibility into throughput, IOPS, latency, and utilization. For example, an EFS system hitting throughput limits may trigger alarms, prompting administrators to move to provisioned or elastic throughput. Similarly, FSx systems expose service-specific metrics that highlight performance bottlenecks or configuration missteps. Continuous monitoring allows for proactive scaling, preventing disruptions while keeping costs aligned with workload requirements. Disaster recovery strategies differ by service. EFS, with its multi-AZ replication, provides built-in resilience, but cross-region replication may be needed for global workloads. FSx, for Windows and ONTAP, support replication features that allow administrators to mirror file systems across regions, providing enterprise-grade DR capabilities. Lustre, focused on speed, relies on S3 copies for durability and cross-region safety. OpenZFS snapshots can be replicated for redundancy as well. By tailoring DR plans to each service's strengths, organizations ensure business continuity without unnecessary expense. Common pitfalls in these services often involve misconfigurations. For EFS, incorrect POSIX permissions can block applications or cause access issues. For FSx for Windows, failing to join the file system to the correct Active Directory domain can prevent user access. In ONTAP and OpenZFS, unfamiliarity with snapshot or cloning features can lead to underutilization of powerful tools. Awareness of these pitfalls ensures smooth deployments and prevents time-wasted troubleshooting avoidable errors. Documentation and training help teams avoid repeating the same mistakes. To make adoption sustainable, organizations should maintain documentation for mount options and baseline configurations. This includes specifying which EFS throughput mode to use, which FSx flavors are approved for workloads, and how snapshots or backups should be configured. Baseline documentation reduces variance between environments and accelerates onboarding for new administrators. It transforms file system deployments from ad hoc decisions into repeatable, governed processes that align with organizational standards. On exams and in practice, cues about file systems can be quickly mapped to the right AWS service. If the question involves Linux and NFS, EFS is the answer. If it specifies SMB or Windows integration, FSx for Windows applies. If the workload is HPC or scratch space tied to S3, FSx for Lustre is the fit. Enterprise data management scenarios involving cloning and snapshots point to ONTAP, while performant NFS storage with low latency suggests Open ZFS. Remembering these mappings simplifies choices, ensuring correct answers in tests and effective architecture in the real world. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.